Good afternoon. Today we are going over note 6.2, which is multiplying and dividing rational expressions. So radical expressions are, again, basically just radicals, right? They have, usually the radicals we've seen have been square roots. Now we'll see cube roots, fourth roots, fifth roots, and things like that. So when you multiply radical expressions, it can only be done if the index is the same. And again, remember the index is the root you're taking. So if you have the nth root of AB, you can split that up as the nth root of A times the nth root of B. You can go this way as well. It works both directions. So you can combine it as one, or you can split it into two. So example 1, we're going to multiply. They're both cube roots. They have the same index of 3. So I can rewrite this as 1. So 4 times 16. And again, now that I'm taking the cube root, I want to find 3 of a kind. So 3 of the same numbers. So 16 is the same thing as 4 times 4. So now I have the cube root of 4 cubed. Remember, the cube root and the cube reduce, so you get positive 4. Okay, if you look at the next one, you have the cube root of negative 12 and the cube root of negative 18. You can rewrite that as the cube root of 12 times 18, right? Because if you multiply them together, they both eventually become positive, right? So I can split this up. This would be 4 times 3. This would be 3 times 6, right? So this is 2, 2, 3 times 2. So there is 3 of a kind. And there is 3 of a kind. So I can take this and rewrite it as the cube root of 3 cubed times 2 cubed. So when you take the cube root, you get 3 times 2. So that gives you 6. Because again, remember, when you're taking the cube root and the cubes reduce away. What's left is 3 times 2, which is 6. Okay, so now example 2. Now we start to throw variables in there, but same concept. They have to both be square roots, which they are. So I'm going to rewrite this as square root of 27 times 3 times x to the 5th, right? Because remember, x to the 3rd times x squared is x to the 5th. Bases are the same. You add your exponents. Okay, so I want to rewrite everything I can as powers of 2. So if we break this up, this is 9 times 3, and this is 3 times 3. So I can rewrite this as 3 squared times, there's another pair of 3's, 3 squared. Now, x to the 5th. 2 does not go into 5 evenly. So remember from last lesson, that means we're going to split it. So x to the 4th times x. If 2 would divide into it evenly, you can rewrite it as 1. Well, x to the 4th, right, this says the same thing as x squared squared. So now when I take the square root, everything with the power of 2, those are going to reduce away, and then those will be outside. So you have the 3, you have the other 3, you have the x squared, and what's left is the x. So it's 9x squared square root x. So these just all reduce away, and what's left goes outside, 3x squared, and the x has to stay underneath the radical because there's only one of them. I need pairs because I'm taking the square root. Next example. So they're both fourth roots, so I can rewrite it as a fourth root. So we got 16 times 12. X to the 3rd and x to the 2nd is x to the 5th. Y to the 6th and y squared is y to the 8th. So now, again, just like before, like we've been doing, I want to rewrite everything as a power of 4. So now I'm looking for 4 of a kind. So 16 is 4 times 4. 12 is 4 times 3. Right? Don't have 4 of a kind right now. the 2 and 2. So there's 4 of a kind. Right? This 4 is 2 and 2, and then the 3. So that's not going to help me, but this would be 2 to the 4th. This would still end up, you could leave it as 12 or 2 times 2 times 3, whatever you want, or 4 times 3, but it's going to end up still just being 12. 4 does not go into 5 evenly, so I'm going to split that up. So x to the 4th times x to the 1. 4 does go into 8 evenly. It goes 2 times. So the number of times is what I'm going to raise it to the power. So y to the 2nd to the 4th power. So now when I take the 4th root, that's going to, again, the 4 is basically reduced with everything that has a 4. So the 2 comes out, the x comes out, and the y squared. What's left is the 4th root of 12x. Because neither one of the 12 or the x were to the 4th power. Everything else to the 4th power will come out. Because you have 4 of those. Okay, example 3. Same idea. We have square roots and square roots. So I'm going to rewrite this as 45 times 35. X to the 5th and x is x to the 6th. Y to the 3rd, y to the 4th is y to the 7th. So again, now we're square root. So I want to find powers of 2, 2 of a kind. So 45 is 5 times 9. Right? 35 is 5 times 7. So there's a pair of 3's and a pair of 5's. So I can rewrite this as 5 squared times 3 squared. And then you still have that 7 as well. Now 2 goes into 6 3 times. So it goes in evenly. So I'm going to rewrite it as 1 power. So this is going to be, how many times does it go into 6? 3 times. So x to the 3rd squared. 2 does not go into 7 evenly. So I'm going to have to split that up. Y to the 6 times y. Y to the 6 is just like x to the 6. 2 goes into it 3 times. So it's y to the 3rd squared. And then the y. So again, when you're working with the variables, you have 2 cases. Either it's like the x's and you can rewrite it as just one single exponent, or you have to split it like the y's and then rewrite one of those. Those are literally the only 2 things you're going to do with the variables, because the index is either going to divide into it evenly and you rewrite it as 1 like the x, or it divides into it odd like with the y's and you split it. So now everything that has a power of 2 gets to come out. So the 5, the 3, the x to the 3rd, the y to the 3rd. And everything that comes out is being multiplied. Everything with radicals inside and outside is multiplication. Whatever doesn't have a square has to stay underneath the root. So that would be the 7 and the y. So then this is 15x to the 3rd, y to the 3rd, square root of 7y. So that's multiplication. Division is kind of similar, but again, it only works if you have the same index. You have to divide by the same index. That means whatever root you have to be dividing by has to be the same. So again, this works both ways. You can split into 2 or you can make it into 1. Whatever way makes it easier to solve. So for example, 4, I'm going to rewrite that as one big radical because they're both square roots. So 50x to the 6th, 2x to the 4th. So why would I do that? Well, now I have a fraction that I can simplify. Right? 2 goes into 2 once, into 50, 25 times. All 4 of these x's will reduce with 4 of those, so there's only 2 left. So this ends up being the square root of 25x squared, which is a lot easier to simplify. So again, rewrite it as squares, right? Because taking the square root, they reduce away, so all you have left is 5x. So whatever index, that's what you want to rewrite everything underneath the radical as, best you can. So if you look at the next example, they're cube roots. So I can rewrite this as one big cube root, 15x squared over 5x. And then I can simplify. 5 goes into 5 once, into 15 3 times. That x will reduce with 1 from the numerator. So what you have left is the cube root of 3x. Now, the last example, I could take the square root. In this case, there's only 1 3 and there's only 1x, so I can't simplify anymore. So that would be your simplified answer. So sometimes when you're working with division and fractions, we can end up with denominators that cause problems. Well, we dealt with that in unit 4 when the denominators was 0, right? That's a problem. Same thing when we have radicals in the denominator. We don't want that. So we're going to do a process called rationalizing the denominator. Right? We do not want any roots at the bottom of the fraction. So we're going to multiply the numerator and denominator by the same root. So, right, if I'm looking at this, I can rewrite that as one fraction, but I can't reduce it. So I want to get rid of the cube root of 3. So if I had the cube root of 3 squared, right, those would reduce away, right, and you would just get 3. So how do I get the cube root or the square root of 3 squared? So I'm going to multiply by the square root of 3, top and bottom. You always multiply the top and bottom by the same value because that's really 1. So again, we've talked about this before with fractions. I'm not changing the value of the fraction. I'm just changing its appearance by multiplying by 1. So when you multiply the numerator, right, root 2 times root 3 ends up being root 6 because it's 2 times 3. Now on the bottom, we end up getting the square root of 3 squared. So what I did was I made a perfect square so that when I take the square root, the square and the square root reduce away. So I created this situation here by multiplying by root 3. So now they reduce. So this becomes 2 root 6 over 3. And that would be your answer. Root 6 cannot be divided by 3. Root 6 is a decimal. So if you divide it by 3, it's a decimal. You can't say it's going to be 2 root 2. It doesn't work that way. So if you look here, right, I want to get a nice perfect 5 squared underneath because that will reduce away and you will just get 5. So this is going to be multiplied top and bottom by root 5. And this should kind of be familiar. You probably saw a little of this when you worked with your special right triangles in Math 2. So on the top we have 3 times root 6 times root 5 is root 30. Okay, and then we end up reducing away, so we get 3 root 30 over 5. But again, I created the perfect square in the denominator by multiplying by the same radical as the denominator to begin with. So I created 2 5s because I was taking the square root. So now if you look at the second to last example, this time it's a cube root. So I'm looking for 3 of a kind. So right now I have 4 and 4. I have 2 4s. If I could get this to be 4 to the third, right, those would reduce and you would get 4. So I need another 4. Well, it can't just be the square root of 4 because when you multiply, remember the index have to be the same. So it has to be a cube root of 4. And the numerator has to be the same value because you need to multiply by 1. So you just change the way the fraction looks. So this gives me the cube root of 4. On the bottom, the cube root of 4 cubed. Those reduce. So it's the cube root of 4 over 4. So in this case, since it was a cube root, I needed 3 of a kind. The last 2 examples, it was a square root, so I only needed 2 of a kind. So in this example, it's a cube root, so this has to be cube root, and this has to be a cube root, because that's the only way to multiply. So 25 is 5 times 5, and then we have x. So I need 3 5s and 3 x's. So this needs another 5, and it needs an x squared. Again, top and bottom have to be the same so that you're multiplying by 1. So you change the appearance and not the value of the equation. So on the bottom, we have the cube root of 5 cubed x cubed. On top, we have the cube root of 5 times 3, so 15x squared. In the bottom, right, we can simplify that. Right, the 3's reduced, so it's just 5x. In the numerator, it's the cube root of 15x squared. And there you go. There's your simplified answer. So that process for those 4 problems in example 5 is what we call rationalizing the denominator. If it's a square root, you need perfect squares. If it's a cube root, you need perfect cubes. So 3 of a kind. And again, when you're working with division, you're going to often be using multiplication because that's the inverse operation of division. So to finish your notes, please make sure you answer the essential question by writing a 3 to 5 sentence summary at the bottom of your notes here. Once you've done that, you are done with your 6.2 notes. Have a great day.